In this lesson, we're going to look at exponential growth applications. So how do I apply the exponential growth model? First of all, let's take a look at the exponential growth equation where we have y is equal to a times b to the x power. And remember that we said that this a is our starting point, or the y-intercept. And then we said that our b is our growth factor. All right, so now we're going to be applying it. And so, again, this a is that starting point. And then we have this 1 plus r, which is our growth rate. So this whole part, or this r right here, that's our rate. And then we have the 1 plus the r, which is the growth factor. So we're separating it a little bit. So this is the growth factor. And then we're going to have the t, our exponent is going to be time. All right, so let's go ahead and apply it now. What it says is in a car purchased in 1984 for $11,000 increases in value at a rate of 6.7% per year. All right, so let's go ahead and write our equation here. We've got y is equal to, and then our starting point, or starting amount, is going to be this $11,000. And it's then increasing at a rate of 6.7% per year. So let's go ahead and turn this into a decimal so that we can work with it. So we're going to have 0.067 per year. All right, and so we're going to have 1 plus our rate of 0.067 per year, and then this is going to be our time then in years. So the value of the car then in 2004, we need to look at, this was purchased in 1984, and we want to know now what the value of it is in 2004. So that means that over time, the time is increased by 20 years. So that's what we need to then plug into our formula. So we're going to have then y is equal to 11,000, the value of it, and it's increasing at 1 plus our 0.067, and the time then is our 20 years. And so then if we calculate this and put that into our calculator, we're going to find that the value of it's going to be $40,247. All right, example number 2, we have a comic book purchased for $55 in 1980, increases in value at a rate of 2.8% per year. All right, so let's go ahead and write our equation for this, or the function. We have y is equal to, and it started at $55, and that it's increasing at a rate of 2.8%, and then move the decimal place 2 places, so you're going to have 0.028. And then our time then, right here. So what we have then is we've got, like, let's do from 1980 to 2012, that was a time of 32 years. All right. So then let's go ahead then and plug in what we know into our equation. We have y is equal to our 55 times 1, and that's just, we could put 0.028, and then our time is 32 years. All right, so then once we calculate this, we are going to then, we are going to get $133.09. So after 32 years, we would then have the value of it would be $133.09. All right, for number 3, we have money in a savings account opened with $500 in 2012 earns 3% per year. So our function then will have the y is equal to, and we put in $500, and then we're going to have 1 plus, and then it's going to be 0.03, then to the x power, or I should say to the t power, because we were talking about the time there. So after 1 year, we're going to have y is equal to 500 times 1.03 to the first year, and we will end up with $515. After 5 years, we'll have 500 times 1.03 to the 5th power. You will end up having $579.64. After 10 years, we're going to have then, and again, you're just going to continue to plug it into our equation, and 1.03 then to the 10th power, and you would end up having $671.96. And then if you continued this and plugging them in, after 20 years, you're going to then have a total of $903.06. And then after 40 years, you would have $1,631.02. So this is after leaving your money in and collecting this interest of just 3%. You have over tripled your money at $1,631 after a total of 40 years. So in this lesson, we looked at how to apply exponential growth model.